好，开始。
Welcome to Asia University Winter Program of Artificial Intelligence. I'm the speaker, D.H. Chen. I will present to you Topic 3, Introduction to Artificial Intelligence, Machine Learning, and Deep Learning, Part 1. This is course outline, week 1 of this winter program. Day 1 yesterday, you have learned Colab, Python, and NumPy with hands-on. Today, I will give you a lecture of Introduction of Artificial Intelligence, Part 1. And there are another Part 2 in next Monday. There are 2 lectures. We will present to you the artificial intelligence, machine learning, and deep learning basic ideas. Let me introduce myself. I work in industry for many years with many roles. In the first company, I lead software engineer, project manager, and product marketing team. And in second company, HTC, I manage ODM and supplier. Now I'm director of technology development and department in Taiwan AI Academy. Taiwan AI Academy is a school. We have vision to use AI to strengthen the competitiveness of industry and nurtures AI talents in Taiwan. Over 3 years, we have over 7,000 graduates in different industries. As you see in the red map, we have 3 campuses from north to south, Taipei, Taichung, and Tainan. We have different programs for technical or for management. And we also provide services and platforms related to AI. I will have introduction later today. For today's course, I believe most of you did not know artificial intelligence well. So I named this is the first class to everyone about AI. And I prepare 4 topics about AI to you today. The first is history of AI. The second one, and the most important one, is machine learning and deep learning, which are the main core of artificial intelligence right now. And the third topic is the status of artificial intelligence right now and the future of AI. And the last topic is how do we co-work with artificial intelligence? Because today we have 3 hours, so I split the course with 3 sessions. Each session have 50 minutes to 55 minutes. So after each session, we will have a break. Okay, let's start to the first topic, history. Maybe you know this person in the left picture. If not, I'm not sure you have watched the movie, The Imitation Game, portrayed by Benedict Cumberbatch in 2014. It's a movie about the Alan Turing. This man is Alan Turing. Alan Turing is a famous and outstanding researcher in many fields. For example, he is mathematician, and he is also logician, philosopher, biologist, and I think most important of all, he is computer scientist, because he is widely considered as the father of theoretical computer science. So the mobile phone you use, the notebook you use, the computer you use, all these devices based on his theory. we call the Turing machine. So he is the father of the theoretic computer science. He is the father. He is also the father of artificial intelligence. We will discuss later. Besides his great achievement in research, he has the legendary life. The first one is he led a team in the World War II to break the Enigma machine from Nazi. Everyone knows that during the war, the message sending from here to there should be encrypted to prevent the enemy to know what you want to do. So Enigma machine is a cipher device developed by Nazi in World War II. So the Alan Turing led a team of cryptanalysts in England to break the Enigma machine's ciphers. This achievement was considered by historians later to shorten the World War II at least 2 years. So, during the World War II, during such a big war, how many lives are lost in 1 month? So 2 years, for 2 years, they saved many lives. So this is the major plot of the movie we discussed previously. And another legend, kind of the strategy. Alan Turing is a homosexual. During the 1950s or earlier, the homosexual is treated as a criminal, even a sickness. So he is treated as a chemical castration. It is painful to his mental status. So he commits suicide later by eating the poison, which called cyanide. If you watch the movie, if a spy was caught by the enemy, he will eat cyanide to kill himself. So cyanide is very, very painful for people. So there is an urban legend that there's an apple found near his body, and the apple was half eaten. So the urban legend is about the logo of Apple Incorporated. Some people think the logo of Apple Incorporated is to pay tribute to Alan Turing, but
Excuse me, sir. Please unmute yourself, sir. Not able to hear anything.
and deep learning, which are the main core of artificial intelligence right now. And the third topic is the status of artificial intelligence right now and the future of AI. And the last topic is how do we co-work with artificial intelligence? Because today we have 3 hours, so I split the course with 3 sessions. Each session have 50 minutes to 55 minutes. So after each session, we will have a break. Okay, let's start to the first topic, history. Maybe you know this person in the left pictures. If not, I'm not sure you have watched the movie, The Imitation Game,
Alexander Turner,
by Benedict Cumberbatch in 2014. It's a movie about the Alan Turing. This man is Alan Turing. Alan Turing is a famous and outstanding researcher in many fields. For example, he is mathematician, and he is also logician, philosopher, biologist, and I think most important of all, he is computer scientist, because he is widely considered as the father of theoretical computer science. So the phone, mobile phone you use, the notebook you use, the computer you use, all these devices based on his theory. We call the Turing machine. So he is the father of the theoretical computer science. He is also the father of artificial intelligence. We will discuss later. Besides his great achievement in research, he has the legendary life. The first one is he led a team in the World War II to break the Enigma machine from Nazi. Everyone knows that during the war, the message sending from here to there should be encrypted to prevent the enemy to know what you want to do. So Enigma machine is a cipher device developed by Nazi in World War II. So the Alan Turing led a team of cryptanalysts in England to break the Enigma machine's ciphers. This achievement was considered by historians later to shorten the World War II at least 2 years. So, you know, during the World War II, during such a big war, how many lives are lost in 1 month? So 2 years, for 2 years, they saved many lives. So this is the major plot of the movie we discussed previously. And another legend, kind of the strategy. Alan Turing is a homosexual. During the 1950s or earlier, the homosexual is treated as a criminal, even a sickness. So he is treated as a chemical castration. It is painful to his mental status. So he commits suicide later by eating the poison, which called cyanide. If you watch the movie, if a spy was caught by the enemy, he will eat cyanide to kill himself. So cyanide is very, very painful for people. So there is an urban legend that there's the apple found near his body, and the apple was half eaten. So the urban legend is about the logo of Apple Incorporated. Some people think the logo of Apple Incorporated is to pay tribute to Alan Turing. But during the interview later, Steve Jobs told the interviewer, "God, I wish you were." So which means it is not for Alan Turing, but it seems Steve Jobs want to do that. So Steve Jobs is the pioneer of technology. He also pay tribute to Alan Turing for his achievement. During this century, the English government pardoned Alan Turing for his homosexual. And in 2019, the Bank of England also used Alan Turing's portrait as the 50 pounds blackface. You know, the central bank of every government, they want to prevent the counterfeit money. So they need to refresh the design of money periodically. So in 2019, the Bank of England announced new 50-pound design with Alan Turing to commemorate the contribution of Turing, no matter in computer science, but also to his achievement during World War II. Let's move to Turing test. Turing test is Turing raised in 1950. As we mentioned before, Turing is also a philosopher. So when he raised Turing test at that time, it's just a kind of the philosophy test. So it is not the so serious scientific test. What is the Turing test? As you see in the left picture, there's the interrogators here. He used the keyboard to ask questions to two roles. The first role is actual human. The second role is a machine. In this example, chatbot is used. Chatbot is kind of the machine. The interrogators cannot note which one is machine or which one is human. So they need a human as an interface. So the interrogator asks question to ask the same question to machine and human. The answer will be brought by these two humans to the interrogator. And the conversation between the interrogator and the human and the machine continue. If the tester cannot, if the interrogator cannot distinguish a machine or a man, then we call the machine have intelligence, which means the intelligence of the machine can let the interrogator think he is the human. So it is a kind of the imitation from machine the imitation by machine to human. So Turing test is also called imitation game. That's the background of that movie, the imitation game. Although in that movie, the major plot is related to the World War II and homosexual of Alan Turing. So this Turing test is raised in 1950. Right now the year passed already 70 years. The machine now basically have intelligence. The first and the famous example is the AlphaGo. It's the AI model developed by DeepMind, and the model defeated the world champion in 2016. So after he defeated the world champion in 2016, DeepMind continued to develop the AlphaGo to make it more powerful than other program or the chess players. In the end of 2016, AlphaGo used the name master in the internet, and it defeat many players around the world. At that time, all the chess player around the world is guessing what is the master, who is the master. He is the man, or it is the machine, or it is the ghost. There's a Japanese animation depicted the story of a ghost from the ancient age to the Japan society and play Go. So AlphaGo in the internet world basically passed the Turing test because no one knows he's machine or he is a human. Another famous example is Google Assistant. I think if you are using a smartphone with Android system, you have used Google Assistant already. In 2018 or even 2019, Google I/O. Google I/O is the Google big event to announce new technology inside Google. In 2018, Google I/O, they use Google Assistant to make an arrangement with the barber, and the clerk in the barber cannot recognize the Google Assistant is the machine. They use the Google Assistant to call that clerk and make barber arrangement, but the clerk cannot find he is talking to a machine. So from definition of Turing test, Google Assistant already have intelligence. So now I will introduce two concepts of AI. One is weak AI, the other is strong AI. Weak AI means that the AI can do a specific task. For example, AlphaGo can play chess, can play Go, and Google Assistant can make an arrangement. But for our human, we cannot do only one task. We can play chess, and we cannot play chess very well, but we can play chess, and we can do other tasks. For example, drive car, cook, or even play sports. So strong AI, the concept of strong AI is that the AI can do general tasks. We call AGI, which means the artificial generic intelligence. So it's a different concept, weak AI and strong AI. And during the Turing test, Turing introduced the concept of intelligence. But for AI, artificial intelligence, which was coined in 1956, there's the big event called the AI project at Dartmouth. So there are a lot of researchers and scientists gathered in the Dartmouth to discuss the future of artificial intelligence. In that event, they coined artificial intelligence first. So artificial intelligence, such a word was used in 1956. Okay, after talk about the history of artificial intelligence, then we talk about the category of intelligence. There are two categorizations of intelligence. The first one is the intelligence can be understood by our human. This is first category. The second category is that intelligence can be gained by learning, just like the human. So based on these two categorization, we have a table like this. Top, in the top is the human can understand. So there are two categories. There are two type of AI. The first one is symbolic AI. Symbolic AI means the AI is a rule-based and the AI can be understood by human. In contrast to symbolic AI, we call the computational intelligence. This intelligence has no rule, and the intelligence comes from computation. What is computation? You can imagine that the computer operation inside its memory and CPU, there are a lot of the operation that human can understand, cannot understand. So it's called a computation. So human is hard to understand that intelligence. So it is computational intelligence. So there are two kind of AI. One is symbolic AI, the other is computational intelligence. So this is one aspect. The other aspect we talk about is about learning. So there are two types of intelligence. One type of intelligence is not gained by learning. So it is fixed. The other is gained by learning. So based on these two categorization, we have three types of AI. The first one is the intelligence is not gained by AI and it is rule-based. So we call it traditional AI. A famous example is expert system. And the other is the intelligence gained by learning. So we have two types of intelligence. First is machine learning, or we call classical machine learning. The other one is the intelligence is gained by learning, and that intelligence is also come from computation. It is called deep learning, or we call neural network later. So these are famous example of deep learning is AlphaGo. So this is the thing that AlphaGo plays the Go with the world champion at that time, the Korean player Lee Sedol. So the AlphaGo developed by DeepMind is using the deep learning. And another famous event 30 years ago is the Deep Blue from IBM played chess with the world champion, Russian player Garry Kasparov. So that is also a big event at that time because Deep Blue defeated the world champion. So in Deep Blue, inside Deep Blue, there is the algorithm. Sometimes we call the brute force algorithm. It is just to calculate the possible play of his opponent. So there's a estimation from the expert. For a world champion like Garry Kasparov, he can predict 10 plays of his opponent. But for Deep Blue, he can predict 12 plays of his opponent. So of course, that's why Deep Blue can defeat the world champion at that time. And they are using the traditional AI, just try to figure out what his opponent will play. So this is the team at that time from IBM. So after we talk about the categorization, we talk about the AI evolution. There are 3 evolutions of artificial intelligence. The first way is from 1950 to 1960. We call the symbolic logics. What they want, what the research want that AI to do is put human thinking into the machine. So they try to ask domain expert. Domain expert means they are expert in different fields. For example, doctor, for example, chemistry, for example, aircraft. So domain expert write down the logics behind their decision. But the result is the human cannot fully understand what they think. We don't know the progress of what we think. So how could we let machine know how we think? So the result is fair. So the first wave AI is fair, and we call it it went to the winter of AI. And in 1980s to 1990s, the second wave of AI evolution comes up. It is called the expert system. So during this wave, the research wants to put our knowledge into machine. So compare with thinking. Thinking is just like a progress of our decision, but knowledge is a kind of result of our decision. So it's some kinds to narrow down their goal from thinking to knowledge. So it could be easier to succeed. So what they try to do is domain expert write down the rules from their experience. So the rule is the result of the experience. But at last, there are too many things we cannot write down as a rules. Of course, no rules, no code, no programs. So the result is some kind of fair. So the AI comes to the second winters. And from 21st century, 2010s to now, we are embraced the third wave of AI evolution. It's called machine learning. So what researchers want is not to put knowledge to machine, but trying to put experience to machine. How to explain, put the experience to machine? The domain expert just provide the historical data. It's just kind of the machine, it's just kind of the experience itself. So domain expert provide historic data to machine and let machine learn the rule by themselves. So that's we have a outstanding AI achievement right now is we are using the machine learning. So the first wave, second wave can belongs to the traditional AI we talked about. And for the third wave, it related to machine learning and deep learning, these two categories. And in the first wave, the most significant event is Dartmouth AI project. And in second wave, the most significant event is Kasparov versus the Deep Blue. It's the chess match. And in the third wave, the famous event is AlphaGo defeat the world Go champion. Okay, that's back to the second wave. Why there are too many things human cannot write down as a rule? Let us look at this picture. There are some people collect many picture, similar picture between animal and food. So in this 4x4 picture, there are two things there. I think everyone can recognize immediately. One is apple, the other is owl, right? So if I ask you a question, can you write down the rule to distinguish the owl and apple? So maybe you noticed the first one is the black circle. Apple and owl both have black circle, two black circles. But for owl, the distance between two black circles is longer than apple. So we can write down the rule. We can use the distance to distinguish owl from apple. And the other one, maybe you notice that the owl has its beak, its mouth, but there's no such things in apple. So we can come out the second rule that if the picture have a peak or have a triangle like a mouse, it is the owl. If no, that is apple. So we come out these two rules. And we go to next picture. It's very interesting. It's the dog, is the muffin. So the dog is Chihuahua. The food is muffin. If we use the rule previously, you cannot distinguish from dog and the food. Why? Because muffin also has a black point, just like the Chihuahua's nose. And the distance between the black points are very close. So you cannot use rule here. But you still can, I believe you still can easily to identify which is dog, which is Chihuahua, which is the muffin. Because maybe some people say the texture of the two things are different. The texture in the Chihuahua is furry, but the texture of muffin is not so flat. So we can use this as a rule to distinguish these two things. But if we provide you another picture pair, maybe you need to come up another rule. So we want to talk about a paradox. It's called the Polanyi's paradox. Paradox means that everyone think it's right, but actually it is not. So it's called a paradox. So Polanyi's paradox mentioned that we can tell then less than we can know. Oh, sorry, I just to introduce the Polanyi. Polanyi is also an outstanding researcher, just like the Alan Turing. He even have a 2 professional position in one university. One professor is from chemistry, the other professor is from economy. So it is very rare that one person can have a 2 different professor in the same university. And he is also a philosopher. So this world, we can tell that then we can know it's from his philosophy research, which means that what we know is hard to tell to everyone. We just know. So it is contradicts to what we understanding. Maybe you think, if I know these things, I know this fact, I can explain clearly about what we know. But in reality, it is not. You can tell everything very clearly. So it is what Polanyi paradox mentioned about. We can tell less than we can know, or we can know much than we can tell. The original quote is, we can know more than we can tell, but I reversed the sentence because I think it's more straightforward. And the other paradox is from Moravec. Moravec is the AI expert. He is also a robot expert. So this paradox is come from, he studied robots with AI. He found for computers, human instinct is more complex than human reasoning. So why we call it paradox? I think if you use this picture to let a 3-year-old child to distinguish dog and muffin, or apple or owl, the 3-year-old child can easily tell you which one is animal and which one is food, because they have very instinct response. So instinct is very easy for human, and reasoning is very hard for children. But for computer, the situation is reversed. Why? Because human instinct has a lot of something that we cannot write down as a rule. So for computer, or for machine, if we want to teach, then what is instinct? We need to know many things clearly. So this paradox, Moravec paradox, is related to the Polanyi's paradox, because we can tell less than we can know. So we are hard to tell everything to computer, to machine. But if we try to do the reasoning, just try to write down the rule one by one, it is very easy to write down as a program to the computer. So instinct is more complex than a human reasoning. So these two paradoxes just to emphasize the fear of second wave of AI evolution, because we cannot write down rule as we want, because we can tell less than we can know. Okay. So we have a short summary of these topics, AI history. The first, I introduced the Alan Turing and Turing test and let you know what is weak AI and what is strong AI. And we have three categories of AI: traditional AI, machine learning, deep learning. And this category is based on two questions. First question is AI can be understood by human. The second question is AI can be gained by learning. And the last takeaway is about the evolution. AI has three waves of evolution. The most important one, the second wave to third wave. The second wave, the human can tell less than human can know. This is planet paradox mentioned. And the third way is we don't need to tell everything to the machine, just provide the data, and that computer summarize its rule. Okay, we will discuss this later. Okay, the second topic is machine learning. It is core of the AI developed today. Let us discuss the definition of machine learning first. What is machine learning? Machine learning is the way to make machine extract rule of decision from data. So you notice there are several keywords in this sentence. The first one is make machine. The second keyword is rules. The third keyword is data. So let us check the example here. We record the voice from different people to say hello. So this is the voice waveform of different people. You know, for a girl, the voice frequency is higher. For a boy, the voice frequency is lower. So there are different waveform for different people. And even some people just say hello slowly. So the waveform will be longer, signal will be longer. So this different voice form all have the same meaning, hello. So the machine learning is trying to learn the hello from this waveform, these voice records. So that is machine learning. So machine learning is human. We don't want to teach machine. We give up teaching. We just let machine learn the rule by itself. So as you see, this is the machine with the machine learning algorithm. He listens different data, many training data. Hello, or hi there, or hello everyone. And use this learning algorithm. He can find the rules that they are mentioned the same thing, hello. No matter what he heard is hello, or hi there, or hello everyone. He can conclude the meaning of what he heard is referred to hello. So this is machine learning. So let's back to the human learning. Actually, they are quite similar. So let me explain human learning more. In our daily life, we repeat an action. We use our knowledge to make decisions. For example, when you get up this morning, you are thinking what breakfast you want to eat. So you are trying to make decision. So the decision should be based on the knowledge you know. So you know the bread, you know the milk, you know the cereal, so you can make decisions. So you have knowledge inside your brain. So you use that knowledge to make decisions. Small decision, big decision, you are repeat this action repeatedly. So the make decision, we expect the decision is the good decision. Of course, it's a good decision. If you made a bad decision, then you will suffer. So we expect the decision you make is a good decision. But how to make a decision is good, we call it learn. So in the right diagram, we show the progress. You have a knowledge in the bottom, the green cylinder. So you base on knowledge to make decision. The decision could be the good decision and the bad decision. And you know there's a gap. You know there's a gap. For example, if you trying to reach some place by different transportation way, you can go there with bus, you can go there with bicycle, you can go there with other ways. You know how long you take to that place. So you know the time. The time longer, the time shorter. So if you make different decisions, you have different time to get there. So you have the gap between the longer time and the shorter time. So learning is to eliminate the gap. How to eliminate the gap? You just adjust your knowledge. So eliminate the gap by adjusting knowledge is learning. So that's compared these two learning, human learning and machine learning. So it's quite similar. For human, we have knowledge, and for machine, they have models, just like the humans, just like the machine's knowledge. Use that model, make prediction. Prediction is just like the decision. And the prediction, we need the more precise to evaluate the result. So we use the word correct and wrong. Of course, the gap between the correct prediction and the wrong decision, they are an error, just like the gap between a good decision and bad decision. We need the error minimized. Minimize means that the error is no longer exists. So your prediction will be a corrected prediction. So the minimized error also related to the model. We adjust the models to let the model prediction next time will be more correct. The error will be more smaller. So minimize and adjust model is called training. And we use the model to predict, it's called inference. So you will familiar with these two words. And these two words is very important for machine learning. Then we talk about the type of machine learning. There are three types of machine learning. The first one is supervised learning. Supervised means the learning is be supervised with an answer. So just like you check the exercise in textbook, I believe everyone write the exercise in your textbook. And if you finish the exercise, you need to check the answer to see whether you are correct or not. So the exercise in textbook, just like supervised learning, you have an answer there, and you know what you learn is good or not. So this is supervised learning. Second type of machine learning is called unsupervised learning. Unsupervised learning means that learning without answer. We have an example here. If a children learn about a cat and learn about a bus, So when the children saw the animation Totoro, he can tell you it is a car with the cat type, cat face. And maybe the children can also tell you that the bus is running. So they don't need to learn this is the cat bus. They can answer correctly. So this is unsupervised learning. And the third type of machine learning is called reinforcement learning. The typical example is the goal. The reinforcement learning is learning with the long-term goal, long-term target. It's different from the answer. So in the chess, we are not to get the result by one play. We need to know the result after many plays. So it is a long-term goal. So it is the reinforcement learning to learn how we achieve the long-term goal. Okay, let's look at the supervised learning first. This picture we just discussed about, it's Chihuahua and Muffin. We saw a lot of photos like this one, and we saw the label from this photo. Muffin, Chihuahua, Muffin, Chihuahua, Chihuahua, Muffin, Chihuahua, Muffin. These photos or these samples have labels, and supervised learning is you use this label to learn what picture is Muffin or Chihuahua. And after you finish learning, I will give you a question. Give you a new photo. Tell us which is Chihuahua or Muffin. So this is supervised learning. And unsupervised learning is you saw a lot of photo, but this photo has no label. And I will ask you the question is give you a new photo and let us know which is Chihuahua or Muffin. This is unsupervised because you don't have label, you don't have answer. And there are 4 typical problems that machine learning can resolve. It is related to unsupervised learning and supervised learning we discussed about. The first problem that machine learning can resolve is about supervised learning. Supervised learning, we know that there are answers or there are labeled. So the first one is classification, which means your answer is class. It's class. So for your personal information, we have a category sex. So you have a man can choose, you have women can choose. So there are 2 classes. And there are also some category called married. So there are 2 classes for this feature, for this category, married or single. So this example are binary classes. We call the binary classes because there are 2 choices, 2 classes. And another example is medical, cancer diagnosis. There are stage 0, stage 1, 2, 3, 4. There are 5 classes. There are 5 classes. And another example is the credit card. We use credit card to buy everything. And the transaction, every transaction of credit card can be treated as a normal transaction or a fraud transaction. Fraud transaction means that some people steal your information and do the transaction. It's a fraud transaction. So it is also a binary classification. So classify is the first problem that machine learning can resolve. The second problem can resolve is regression problem. Regression problem means that the answer is numerical. It's a number. It's a continual number, not just like the class. Class is the individual one. So for our personal information, the notable information of numerical is height and your weight. And for our environment, temperature is also numerical. 50 degrees Celsius, 50.1 degrees Celsius, 50.2 degrees Celsius. So it is continuous number. It is numeric. It is not a class. And another example is the gas concentration. For example, CO2, 5% CO2 or 10% or 50%. So there are two typical problems that machine learning can resolve. Of course, in the real world, there are not only this kind of answer, this kind of problem. A famous example is a sentence. If you have used the chatbot, if you type some word to the chatbot, and chatbot will feedback you another word. For example, if you type chatbot, how is the weather today? The chatbot feedback to you, sunny with cloudy. So their feedback is a sentence. It's not a numeric answer. It's not a class and it's not a class. So it's a sentence. So of course we can use some technology to transform the sentence to some problem that we can resolve. And this is the further technology. Maybe we will discuss later. This is problem we can resolve for the supervised learning. And how about unsupervised learning? There are two kinds of problems. Before we discuss these two kinds of problems, we just explain a table of data because it is the quite common data representation. The table of data, we have samples, or you can call it record. Sample 1, record 1, sample 2, record 2 to the sample n. So you have n samples. And for each sample, for each record, you have different features. For example, if this sample is related to a person. So the person, we can have a lot of features. For example, what we mentioned previously is about the height, about your weight, about your name, your address, your sex, and your marriage status. So you can have many features. So this is the common representation of data. So you have samples, you have features. Of course, for the supervised learning, you have another feature or you have an answer column. So this column labeled the answer for these samples, this record. Label 1, label 2 to label n. Of course, this label can be duplicated, not just different. For example, what we discussed, the sex. The sex is binary, so maybe the answer can be binary, can be man, woman, man, woman, man, woman. Okay. After you understand the structure of table of data, let's go back to the problem machine learning can resolve for the unsupervised learning. The first one is clustering. Clustering means that make a lot of data to different clusters. So its target is for samples. So we don't have the classes definition for our data, but we can group the sample according to some clues. Some clues means some feature or some observation. For example, you can group your customer into several clusters by their transaction record. If you don't have answer, but you can group your customer with some clue. And the other example is in the media database, you have a lot of photo and a lot of video. How to arrange these photo and videos? We can find similar photos and make a group, and find other similar photos, create another group. So this is clustering. And maybe you heard a marketing example called beer and diaper. This is the interesting story that a convenience store just found some interesting fact is that during the Friday night, the sale of beer and sale of diapers has highly related, has highly corresponding. So they study why people buy beer and buy diaper as well. They find the fact that the people buy beer and buy diaper simultaneously are the young male who has just have children. So they investigate further and found the fact that is during the Friday night, his wife told his husband go to buy the diaper, and the young husband just want to drink beer and watch the sport game during the weekend. So they buy beer as well. So it is very interesting finding that the beer and the diaper, these two things is quite irrelevant, but they have appeared at the same time. So it is an example of clustering, just trying to analyze the data you got. If you don't have answer, you can try to clustering them first. This is clustering problem. The second problem of the unsupervised learning is dimensional reduction. It's kind of the mathematic term. And dimension is just features. So if you have many features in mathematics, you have many dimensions. So dimension reduction means that you need to reduce the feature because the amount of feature in some cases is very huge. For example, during the manufacturing, there are a lot of parameters you can collect. And right now we are in the IoT age. I believe you will learn IoT later. IoT is Internet of Things. So the key point of Internet of Things is they have many sensors. Many sensors means that you can collect many data. So in some cases, your features can have thousands, tens of thousands, hundreds of thousands features. So it is very huge to computation. The computer maybe need a week to come out some model or come out some result. So we need to integrate. We need to integrate this feature for further computation. A simple example is personal information. For example, the personal information, you will have weight, you will have height, and you also have the BNI index. You know the BNI index comes from the calculation of weight and height. So you can eliminate BMI if you think weight and height is important, or if you want to leave a single index, you can leave BMI and remove weight and height. So this is a very simple example of dimension reduction. Okay, let's go to the reinforcement learning. As we mentioned before, reinforcement learning is learn a long-term goal, not an immediate answer. So I'm not sure during your childhood, maybe your parent asked you what you want to do when you grow up. Maybe you told your parents, I want to be a scientist, I want to be a doctor, I want to be a firefighter, I want to be a pilot. So this goal is a long-term goal. It cannot achieve just in 1 year, 1 month, or 1 hour. You need to spend a lot of time to reach that goal. So reinforcement learning is in our life. And in machine learning, the reinforcement learning, there are several factors. Let us look the picture in the right. There is a mouse in a maze. He need to find a cheese. So he need to find a way to the goal. The goal is where is the cheese. So the environment will give the mouse observation. The mouse based the observation to make action to go some direction. And finally, he will get a reward. The reward is he got the cheese. So for reinforcement learning, the key point is interactive with environment. Observe, act, and try to reach the best result. So this is a typical example of reinforcement learning. So if you remember, we discussed about the goal. The chess is similar to the maze and the mouse. So the proper problems that reinforcement learning can resolve is we have an environment which can feedback precisely. For example, the mouse in the maze. The mouse go one direction. If the direction is allowed the mouse to go forward, then the mouse can go forward. If the mouse face a wall, of course, he cannot go further. So the maze can give the feedback precisely to the mouse. And another important factor about reinforcement learning is that the human can simulate the environment. Why we need to simulate the environment? Because we need to try. For the mouse in the maze, maybe he can just try once, but we need our machine learning to learn the best knowledge to finish our goal. We need to try many times. So we need to simulate the environment so that we can try many times within a reasonable time, not many years. So there are 3 types of the problem fit suitable for the reinforcement learning. The first one is chess. just like the AlphaGo we discussed about. And second one is the PC gain or TV gain, because as long as your PC is power on, you can try many times. And the third one is self-driving car. Maybe using the driving car, if the driving car crash, happen to accident, the car just gone. So why we can simulate the self-driving car? Because there are some road simulation, can simulate the road status. So self-driving car can simulate the driving strategy in that environment. So self-driving car is also a suitable problem. It's also a problem suitable for reinforcement learning. This is another example of reinforcement learning. StarCraft. DeepMind finished the AlphaGo program. They want to find another more challenge topic. So they moved to StarCraft. StarCraft is the video game, which is the strategy, And of course, the game, such strategy game is more difficult and more complex than a chess or Go. Because for a chess, the player can view the global situation at one glance. But for the game like the StarCraft, you just have a visibility of a local area. So you don't have a global visibility. So it is more difficult than the chess. So here we show is the dashboard of the StarCraft, or we call the AlphaStar. AlphaStar is the AI model for the StarCraft, just like the AlphaGo. The AlphaStar dashboard here, in the left button, we have the observation, just like the maze in the mouse case. And we have an activation neural network, which means they use the model to calculate what they can do. And the result is consider location. He will move to which location. And the final is the outcome. Outcome means that the goal we mentioned, the final goal. For the StarCraft, the final goal, win, lose, or draw. Here is the possibility. And there are some parameters here to adjust. And this is another interesting example of reinforcement learning. He used a human-like body to try to simulate a man stand up and run. Let's take a look. As you see, there are many tries and fail. So if you found the stop, it means fail. And in the bottom is the iteration, or how many tries they are trying to do. So the action of this human is trying to stand up and run and try to adjust the joint of this running. This is another example. A spider-like is trying to learn how to move. quickly. So it is a very interesting example of reinforcement learning. Okay, we'll just stop it. So let's talk about the approach of machine learning. There are many approaches of machine learning. We will introduce the 4 approaches of machine learning in next class. Let me introduce these 4 approaches first. The first one is regression based. There are 2 types of the regression. The first one is a linear regression. Linear regression is trying to find a line or a plate to meet the training data. And the logistic regression is a binary, is a regression to meet the binary classification. And in the top right is called the SVM. We call it support vector machine. It is a very famous method before deep learning. The concept of the support vector machine is trying to project the data set into higher dimension and find a simple plate to separate the data set. And the left button is the decision tree. Decision tree is the simulate the people make decision. There are 2 ways for one decision. For this example is for a bank to check whether to loan to a person. So the first checkpoint is the account of his person, whether balanced over $200. Yes or no. If yes, if no, then the bank need to check his working status. If his employment is over 1 year, then it is credible for loan to his person. So there are many decisions, and we can have result in the list. So decision tree is trying to build up a decision tree. Decision tree is trying to build up a tree that can meet the data set and its answer. The right button is neural network family. We will explain later. It is deep learning. It is called deep learning. So in regression-based, support vector machine, and decision-based, we call it is classic machine learning. And neural network, we call it deep learning. And last, we will explain the flow of machine learning. It is some kind very common to other problem solving. So maybe it's not dedicated to machine learning. If you're trying to solve other problem, the first, you need to define the problem. Second, you need to collect the data related to that problem. And we need to do some cleaning action because some data have corruption or other problems, so need to clean up. You have problem, you have data, and then you use that data to build the model. And we need to check the model is good or bad. So we need to analyze the result of that model and then refine the model. So you will see that some line go back to the previous stage. Maybe you need to refine model. Maybe you need to check your data. Maybe your data is not good enough. or even you find the problem you define is not precise, so you to redefine your problem. So it is the cycle process and final result. If everything fine, then you go to final result. Okay, and we talk about machine learning. The concept, we explain the human learning and the machine learning. They are quite alike, and we explained the three types of machine learning: supervised, unsupervised, and the reinforcement. And we also introduced the typical problem that machine learning can resolve: classification, regression, clustering, and dimension reduction. And we just brief the approach of machine learning, including classical machine learning and deep learning. And finally, we explain the flow of machine learning. You need to define your problem, you need to collect data, and then you need to build your model. Okay, this is the first session of our class. Let's take a break. Welcome back. Let's start our second session. We will talk about deep learning. This picture is shown by NVIDIA many years ago. I think this picture is clearly indicate the relationship between AI, machine learning, and deep learning. So what is the deep learning? So we start to explain artificial neural network. Actually, the artificial neural network is to simulate the physical neuron. So as you see, the left picture shown the biological neuron, and we simplify the structure of biological neuron to right picture. It is simple form of neuron, so we call it is the perceptron. So it is the new term, perceptron. And we recapped what we discussed before about machine learning. The machine learning have two stages. The first stage is inference. Use the model to make prediction. The second stage is training. Training is try to adjust the model to minimize the error. So I believe you have memory about the concept. So we will explain deep learning with these two stages. Okay, the first stage, inference. So we have the simple form of neural network in the left picture. So this form neural network is the model we mentioned before in machine learning. And in some explanation of this neural network is just use mathematical way to explain how they operate. So x1 times w11 and add b1 and going to activate function, result the output. And here I want to explain the inference of neural network in a more intuitive way. I will use the human behavior to explain how neural network inference. We discussed before about the making a decision. So inference or prediction of the neural network, you can simulate, you can try to understand the concept is like to make a decision in your behavior. For example, you want to select a restaurant and you don't have idea. So the first step is you try to collect information from different sources. So this is X stands for. X means input, X1, X2, and X3. For the case of restaurant select, you have some information, you have some advice from your friends or from your family or from your neighbor or from some government. So you collect different information from different sources. And this information have some weight. The weight means how do you trust that source? For example, you trust the government in the internet from his blog. So you have high weight to that source. For example, the weight can be 90%. And if for some source that you don't trust so much, for example, your neighbor, he told you which restaurant is good, maybe you have no interest, so the weight is low, maybe 10%. So 90% versus 10%, this is weight means. And of course, you cannot rely on others. You should have your own idea. You should have your own comment. So this is bias or justice or prejudice or prejudice. So this is your ideas. So your ideas and the others' ideas and add together. And then we go to a activate function. Activate function means how you decide. We don't explain detail here. It's just like a transformation from linear to nonlinear mathematic way. So after activate function, you have your result, you have your output, you have your decision you make. And for some decision, you need to from different aspect. So you have Y1 and Y2, you have two results. Take the selecting restaurant as an example. Y1 could be the selecting from taste. Y2 could be selecting from the distance. So you can use these two results, make a final decision. So I used the human behavior to explain how neural network work. Okay, let's go to the another stage, training. Maybe you remember why we need to train, because our prediction is not correct. So we have error to minimize. And how to minimize? We need to adjust models. This is training. So when to train, the prediction and the actual result are different. So actual result means the answer. So the actual result is wrong, and the actual result, of course, is correct, and your predicted result is wrong. So these two results, these two Y have different. We need to train. So when need to train, when they are different, we need to train. And what purpose of training? From this page, you know we need to adjust the model. The model means the neural network. The core of the neural network is the weight. So we need to adjust the weight to make the predicted Y equals to active Y, which means error is zero. Error is zero. So how to adjust? We just explain the idea. Equal means subtraction to zero. So zero means very, very small. So from mathematical explanation, we have some way to minimize the result. So there are a method, a traditional method, a method developed a long time ago, which called gradient descent, is used to minimize. We will not explain gradient descent here. We will explain gradient descent later for detail. And there are some improved for gradient descent. Improvement is called the backpropagation. We did not explain here either. We will explain further in the second part. But please memorize these two terms. It's very important. Gradient descent and backpropagation. Okay, we just explained the operation of neural network and why we use deep learning. Actually, deep learning is equal to the term deep neural network. Why we call deep? The example we showed before is very simple. It's just we call the one layer of neural network. But in reality, the neural network operate with many layers and can has neural network power. So there are many layers. For example, 100 layers. So deep means the many hidden layer. Hidden layer means the layer in between input layer and output layer. So deep neural network means the neural network with many hidden layers. Why we call deep learning? So it is the interesting story. As you remember, there are some AI winters between evolution. So neural network already developed long time ago. A pioneer we will introduce later called Geoffrey Hinton. He studied neural network for many years, but during the AI winters, neural network is quite unpopular in academic society. So if you submit paper of neural network to any event, to journal, to symposium, basically that paper will be dropped because neural network was deemed as useless. So during that time, Geoffrey Hinton, he tried to let his paper accept. So he just to combine deep neural network and machine learning. Machine learning at that time is popular. So he combined deep neural network and machine learning, comes out the new term, deep learning. And he used the deep learning for his paper and finally accepted by the journal. And people finally find the deep neural network is quite useful. So there's a story here. Let me recap the approach of machine learning. As you remember that regression, support vector machine, and decision-based, we call it the classical machine learning, and neural network we call the deep learning. So here is the study that the data and model versus the accuracy. We use the two approach, the neural network and other approach. Other approach is what we mentioned in previous page, is classical machine learning. So classical machine learning and deep learning, neural network equals to deep learning. So as you find the curve, If the data or the model is simple, the other approach have a good performance than the neural network. The accuracy is the metrics of performance we will expand in our second course. So just the performance of the machine learning outcome. So if the data is small, the model is small, the traditional way or the classic machine learning is outperforming than neural network. But if the data become larger, model become more complex, the neural network will outperform other approach, which means the basic or classic machine learning. So there's also a timeline here. After 1990s, there are more data come out, there are more models, more complicated models come out. So neural network is hot, is popular than machine learning. And as I mentioned in the previous session, IoT era, we are in the IoT era. There are a lot of sensors there, so we collect a lot of data. So this lot of data is quite suitable for neural network. So that's why neural network, why deep learning is popular than machine learning, than classical machine learning. So let us to see the reasons behind the deep learning boom. The first reason is theory ready. So we just talk about the deep neural network. We will explain convolution neural network and RNN later. So this theory is already there for we used, and there are some improvement, as we mentioned in the previous page. For DNN, we have a traditional mathematic method called gradient descent, and we have improvement called backpropagation. Backpropagation is invented by the Geoffrey Hinton I just mentioned in the previous page. He is called the father of the neural network. And CNN is another neural network. It has a basic calculation called convolution. And Yann LeCun, another expert of deep learning, he tried to use the neural network to calculate convolution. So send us a DNN, send us a deep neural network, a traditional way and an improvement, and make the theory of neural network is easy, faster to calculate. So we will discuss CNN later. And second reason is hardware capability. You may hear the law, Moore's law. The hardware capability is stronger, getting stronger over decades. So a famous example is NVIDIA GPU. The GPU original purpose is used for graphics, for gaming, but now they can use to train the AI model. And for NVIDIA, they create some platform, platform for their hardware. It's called CUDA. So hardware capability is also to push the AI to the boom. So NVIDIA, this picture shows the NVIDIA CEO Jason Huang. And so for computational complexity, lower and lower because there are many improvements for example, backpropagation or neural network noise. So complexity become lower and lower, and computing power higher and higher. It means that the hardware capability is more stronger. This result that the complexity going down and the power going up, so they meet a sweet spot. I call the sweet spot of artificial intelligence, so that the use of AI, use of neural network can be finished in a reasonable time. For example, hours. If we have such a improvement of theory and we don't have such powerful hardware, maybe the calculation need weeks or months. So it is very, very important for AI from theory and hardware capability. And the third reason is the big data. The data is very important for artificial intelligence and machine learning, deep learning. So besides the IoT I mentioned, there are some research to collect the data and let the academic use for further theory. The most popular one is called ImageNet. ImageNet is a big image database with 14 million image and 21,000 category. It's a very, very big database. It is collected by the Fei-Fei Li. He's a professor in Stanford. So he spent many years to collect such a big database and use that database to host a contest. The contest is let every researcher, every